Thank you all for joining our spaces today. We're going to be talking about all things oracles today, and we're joined by an esteemed guest here. We've got Rick Pardo, who is a co-founder at Liquity and also our lead engineer at Liquity. We've got Jayant from Pyth Network, who is the CTO there, and we've got Jakub, who is the founder at RedStone. Hope all of you guys are doing well. Today's topic essentially follows us going into a deep dive into oracles, kind of shedding some light as to why we went through the process of kind of doing some research findings on oracles. I guess I can give a high level overview, but probably it would be better, Rick, if you could kind of set the stage as to why we conducted the research around oracles and V2 and what is the whole purpose of it. Right. So just to set the stage for us, while researching for V2, we want to have essentially create a stablecoin that is scalable, secure, and decentralized. And obviously, this new system, we want to improve upon the limitations that LUSD has in terms of scalability. And obviously, when it comes to this, one of the key things that we need to figure out is, how we can incorporate oracles that fit those three criteria. Rick, I'll give you the stage now to kind of talk through the research that we did and so your findings from it.
Sure, sounds good. So just to test, can you hear me at the moment?
Yes, I can. Yeah.
Okay, good, cool. Yeah, so as Sam mentioned, we're launching a new system. The working title is Bold, and it's a state ETH-backed stablecoin. So it has a reserve with free minting and redeeming, where users deposit state ETH collateral and they mint the stable coin. And it also contains hedging positions, which are leverage positions on state ETH, which also help back the stable coin. And so, yeah, for this system, we need a way to actually price that collateral. And so therefore, we need an oracle feeding the state ETH USD price. And yeah, so basically then the question is which oracle should we use, or which oracles, plural, and what criteria or what properties should they have to be a good oracle and a good fit for our system. So the system's intending to be immutable. So once it's launched, it will be set in stone. We won't be able to change anything about it. So for that, we need an oracle that's compatible with that. So we need an oracle that we can kind of be sure that the interface won't change, that it will the oracle we're connected to at the start will remain the oracle that feeds us the price. And also, because we're immutable, it kind of means that we maybe have a sort of higher bar for oracle selection than a system that has governance. Because if you have governance, you have some slack. You can actually set a new oracle or make a decision to change the oracle at some point if something goes wrong. If you're immutable, you don't have that luxury. So you really need to be kind of 100% sure it's the right oracle with high enough attack costs and is going to continue feeding good quality data for hopefully decades. And then also another property we want in the oracle is potentially low latency. So this may be important. Obviously, the lower the latency, the more accurate the price is, which is potentially good for mitigating front running, particularly with leverage positions. But there are other ways to mitigate front running as well. So yeah, it's debatable how important that is, but obviously the lower latency, the better.
Perfect. Thanks for that, Rick. I think that as a result of that, what would be great is to hear from both RedStone and Pyth, who are here today, to kind of discuss more about your oracles and where they're currently being used in DeFi as well. Jayant, I'm going to give it to you first to maybe give a little bit of an introduction of Pyth, and yeah, please take the floor.
Sure, thanks. Thanks, Sam, for having me, by the way. Appreciate it. So Pyth is basically an oracle for financial market data. The core idea for building Pyth came out of the realization, the key thing about Pyth is that it's a first-party oracle. And what that means is that the owners of the data are actually the ones contributing that data to the oracle. And the reason for this is because if you look at the traditional finance markets, you will see that a lot of the major exchanges and players charge a lot of money for market data. Market data is not free, right? So NASDAQ makes something like 20% of the revenue by charging people for market data. So if you think that the crypto markets are going to play out in sort of a similar way, you're going to end up in a situation where it's going to be hard to access this data in the future without someone paying for licenses, and the sort of third-party relaying model just isn't going to work. So we kind of went down this path where we said, look, in TradFi, it works like this. Let's build an oracle where we can actually get the owners of the data to contribute it. Those owners actually get a financial incentive for contributing that data so that they're happy to share it. And, we went out and we found a bunch of different, we talked to a bunch of exchanges, we talked to a bunch of, market makers, trading firms, and we got a lot of interest in the idea. So, right now Pyth has about 80 first-party data providers. These are, some of the biggest names in traditional finance and crypto, like Binance, Coinbase, SIBO is like the second biggest equity exchange in the world. Things like that, Jane Street, Two Sigma, some really big players contribute their pricing data directly to Pyth. And so when we were building Pyth, I guess I'm kind of walking you through the journey here, but when we started Pyth, we started it as an oracle on Solana. So, we launched it maybe 2 years ago on Solana mainnet. We kind of quickly grew to be like 90% of the value secured on Solana. So, a lot of the big Solana apps like Solend, Mango Markets, things like that are using Pyth oracles. Then about last year, we kind of realized that we really wanted our oracle to be available on every blockchain because, developers are working in different environments. There's good reasons potentially to work in different environments, and we just don't know how the whole ecosystem is going to play out. So, as an oracle, we want our pricing data to be available everywhere. And so we kind of went down this journey about how do we go and deliver that data to different chains. We kind of came up with this pull oracle model, which I'm sure we're going to talk about later. And basically, we launched that last year. We've seen a lot of growth on that pull oracle. We've got some users. Some users are like synthetics. There's a bunch of perpetual protocols on a bunch of different chains like Vela that use Pyth network. So we've seen a lot of growth of that across. Oh, we've got some like Cosmos users, like Injective, for example, uses Pyth oracles. So a lot of different users of that pull oracle as well. We've seen a lot of growth of that over the past year. And basically right now, what Pyth offers is sort of two different products. The first one is real-time price feeds. That's exactly what it sounds like. They're price feeds that update, every 400 milliseconds that can be used on every blockchain that Pyth supports. We have about 300 different assets supported there. Those range from cryptos to equities to, commodities, FX. I guess for the purpose of this conversation, it's only staked ETH that matters, but, so be it. And then the second product that we have is benchmarks. This is basically historical Pyth data. Turns out a lot of people want this for like, plotting price graphs or whatever. So that's another product that we offer.
Thanks for that, Jayant. Jakub, if you could do the same for RedStone as well to give us an idea of where it is being used and a bit of context about RedStone, that'd be great.
Absolutely. So thanks for having me. I think I always respected Liquity for having this proper due diligence process, as we've had many conversations. I think it's super important for every protocol in this space to put a lot of attention to the quality of oracles. But now a few words about RedStone. So when I was founding RedStone, it was roughly 2 years ago. So we are like a younger brother of Pyth, but the time difference is not so significant. And it allowed us to work on a, let's say, new design, learning from the behavior of the more popular and older oracles. So our approach was to be more flexible and also scalable. And we've been promoting the pool data model. So you only pay for the gas cost when you consume data. As in our view, it was the only way for the broad DeFi space to scale and to consume more feeds. So at the moment, we can provide data for more than 1,000 feeds. And also talking about the price discovery process and about our data providers, we got 3 different categories for that. So the first one is very similar to Pyth, which is like kind of the first party data providers, which are the trading companies or the enterprise level aggregators. The second one is like a direct access to all of the off-chain exchanges. So we got more than 50 of them, and you can fetch the prices directly, which turns out to be the fastest way of collecting information. And also, which is becoming more and more important and prominent when you speak to customers, is this third approach to fetching data, which is based on an access to on-chain indexes. So that's something unique about RedStone. And as we started monitoring the landscape for stake Ether, obviously we got Lido, which is an amazing company, but there are a few others players, and most of the liquidity for the others, like for example Swell, is still being traded on DEXs. So having direct approach and a reliable way of querying multiple DEXs, monitoring liquidity, aggregating the data, and providing that could be a really important factor for the RedStone growth in the future. Talking about our adoption, we got at the moment over 100,000 on-demand transaction facilitated in productions on a few networks like Avalanche, Mainnet, Arbitrum, etc. We work with more than 20 protocols at the moment. And what we are really interested is to focus on the new wave of DeFi, which are perpetuals, which are options, and which are like the automatic strategies. And that's probably the core of our current user base.
Cool. Thank you so much, Jakub. One of the things I think Rick mentioned earlier, and I want to kind of chime in on as well, is the challenges that we foresee with front running, especially when it comes to V2 and some of the solutions we're looking at. So just for some of the audience members who want to know what front running is, it's essentially when a trader sees the market price move and exploits that information with an on-chain operation before the on-chain price has caught up with the market price. And in V2, this is kind of an essential challenge to solve because it can be an issue in a few ways, right? One is when you have a leveraged position, a user could essentially open a position as a front run to an anticipated price rise, then quickly close that leveraged position after the price updates on chain. And that way that person could gain an leverage amplified profit. And the same goes on the opposite direction as well for loss evasion. So a user could have a position that's already open on V2. They can close it as a front run to an expected price drop and then immediately reopen it again after the price updates on chain. That way they avoid a leverage loss. One question that I had for both of you guys, let's start with Jakub this time, is, how do you guys address front running? And I know RedStone in particular has, I believe you have self-serve and deferred settlement, right? As ways in which you go about this, but it'd be great to hear as to, what are some approaches that you guys have in mitigating front running?
Mm-hmm. Yes, totally. So I think first important, but not sufficient ingredient is to have like a low latency data. And we are testing at the moment like the sub-second frequency of data delivery. But obviously you still got this 1 second or even like a half second when you can try to front run the price delivery. And as you mentioned, we get through two modes. The one we call internally core, which is like a self-service mode, is a mode when a user can bring the data on his own to the protocol. And obviously we perform the full verification, checking the timestamp signatures, etc., to make sure that the data is of the quality that the protocol is expecting. Also, what is really important here, we spend a lot of time, like almost a year, trying to optimize it to the limit. So the gas cost for a single feed is around 15,000 gas unit, which is also like a very important factor if you want the price to be updated often by a lot of users. So basically, they will be paying the cost. So if you can reduce this overhead, that's great for the protocol users and in the long time for the protocol itself. But obviously, there's like a question if the user is bringing the data on chain, the data at the moment when it's being received by the protocol, there's like a small window. So during that window, the price could be somehow front run. So a user may know that the price has changed, but takes the slightly older data package, maybe like a 2 or 3 seconds older, because obviously we need to have a small margin to cater for the time that is necessary for the data to be mined on chain. So we also got a second approach, which is an extension of the self-service model. We call it like a Model X because it was a co-design when we been working with the GMX on their version 2. And in that scenario, there is a keeper service that is watching the on-chain activity in the protocol. So for example, when there is an event or even a transaction for opening a position or like a long position in Liquity or simply like trying to mint some tokens, then this request is recorded on chain, but only settled afterwards when the price is being delivered to the protocol. So during this request phase, we record on chain the timestamp, and we required the price to be delivered that is being sourced exactly at this given timestamp, which prohibits any form of manipulation. And also, what is interesting, this keeper service could be either performed by our own keeper nodes, the nodes could be hosted by anyone else. It's possible to implement a way to refund the gas costs, but also it could be open for any external users to bring the price because we can check and verify on chain that the timestamp for the price matches the requested timestamp when the intention was recorded in the protocol.
Thank you very much, Jakub. In light of that, Jayant, how does Pyth differ in the way in which it counters front running? And also, if you could give some like examples of some protocols that are how they're using Pyth at the moment.
Yeah, happy to answer that. I mean, before I do that, though, I think it's good to just take a step back here and be very clear about how to think about front running and latency, because I've definitely seen some people in the space kind of thinking about this the wrong way. Not saying Jakub's thinking about it the wrong way. I think he's actually thinking about it the right way. But I've seen, public writing and stuff like that, where they think that the problem is like the Oracle price itself can be like observed somewhere before it shows up on chain. And then like someone can see that exact Oracle price and then use that information in order to like do something on chain or front run it or whatever. And I guess like the thing about this that so in that view, right, the thing that you need to do is like you need to like hide the Oracle price. You need to like hash it and put a commitment or something like that, right? And like I think this is just the wrong way to think about the problem, because the Oracle price itself is actually very predictable from other information. If you're looking at exchanges and things like that for the price of the asset, you have a pretty good idea of what that Oracle price is. And that prediction of what the Oracle price is just as powerful as like knowing the exact number, essentially, right? So all the same attacks are available. So basically my point here is this is not a question of like hiding the Oracle price. That's like not the right way to think about it. Okay. And then one of the reasons I want to bring this up is because like, when you're thinking about front running, right, you don't really want to think about it as like a binary thing, right? You need to think about this kind of like a market maker in traditional finance, right? And I think there's a set of nuanced questions that you really want to ask here. So the first one is, how long does it take the protocol to know about price movements, right? So this is kind of a measure of latency. The second one is, how much can the price actually move in that time, right? So this actually depends on the asset. This probably depends on some, empirical estimates of volatility or something like that. The third one is how much damage can someone do with that knowledge? And the fourth one is, if like there are those price movements and your protocol takes losses, like can you offset that with gains from other places, right? So this is basically how a market maker thinks about putting orders on the market, right? As a market maker, you're not always going to be the first person to know about a price movement. You're going to get some toxic flow. You're going to lose some money in those cases, right? So, they're doing things like tinkering with the spreads and things like that, adjusting other parameters of their algorithms to sort of ensure that, the losses that they take in the cases where the price moved against them and they didn't know about it first are offset by gains from, other users who are just like, trading one way or the other. They don't maybe have any particular information. So once you start thinking about it this way, you realize that there's a bunch of different parameters in the protocol that you can adjust to kind of solve this problem. It's not just a matter of like optimizing for latency or something like that, right? Certainly latency is one of the parameters that you care about, but you can also do things like adjust spreads or adjust loan to values to kind of help combat this issue. Okay, so how does Pyth actually deal with this problem? Well, this is going to be sort of anticlimactic because we basically do the same thing that Jakub was talking about. You can do this sort of self-serve model where when you submit the transaction, you put a price update in there. That obviously has higher effective latency. There's effective latency for the time it takes someone to sign the transaction, all this stuff. So that's slower, right? But for some protocols where like you're not super sensitive to latency, it's fine, right? If you have a lending protocol with highly conservative loan to value limits, this probably isn't going to kill you. And then the other option is delayed settlement. This is actually what pretty much everyone uses in practice, but this is where basically people place a request to do the operation, and then it's sort of fulfilled with the keeper at the price at that timestamp. So like this is actually what pretty much everyone's doing. A lot of the Pyth users right now are perpetuals protocols who are like very latency sensitive. So like Synthetics is doing this, Vela is doing this. Pretty much everyone's doing this actually.
Cool. Thanks very much for that. I think that's very good context to have when thinking about oracles. Rick, I do have a question for you now. Obviously with V1, with Liquity V1, the immutable nature of it, we obviously had quite a complex backup oracle design that we built into the protocol as well. Could you share maybe a few learnings that you learned from V1 and what you're thinking about for V2?
Sure. Yeah. So just for some context, because it was immutable, we were pretty wary about just connecting up to one oracle and launching. We thought, we were kind of paranoid about what happens if that oracle fails or freezes or becomes malicious in the worst case. We were thinking like, how can we have some contingency so that if that worst case happens, maybe we can switch to a different oracle and the system will keep operating. So we kind of came up with this this fallback design where we have a primary oracle and we switch to a secondary based on some failure conditions. And I think that design is pretty sound. I think it's like a good way to go rather than trying to take a median or take an average of multiple oracles where you can actually end up introducing potentially even more attack surface area. It depends how you do it, but so this idea of like a primary and a secondary, I think was quite sound. But I think one big learning we had was around the complexity of the implementation. So we spent a lot of time really like kind of trying to hash out the logic of this and come up with this quite complex fallback logic and have it switch to the fallback if the primary breaks, and then try and switch back to the primary if that comes back online, and look for conditions that we can use as a signal to switch back. And it was this complicated kind of structure. And by focusing on that too much, we actually kind of missed a piece with the basic integration with the secondary oracle, which was Telor. And actually, the Liquity V1 used Telor incorrectly at first. And basically what happened was we were pulling the current price from Telor when we should have been pulling a lagged price, because the way Telor works is prices need to go through some dispute period to be kind of verified as accurate. Otherwise, anyone can just kind of submit a fake price. And so yeah, like Liquity had never actually switched to Telor. It was always using the primary Oracle Chainlink, but had it switched to using Telor, then it could have been vulnerable. Yeah, luckily Telor are actually able to implement a fix on their side, because yeah, we can do it on our side because Liquity is immutable. So they managed to make it so that Liquity sees a lagged price instead of a current price. So yeah, the lesson really is like kind of just we over-indexed on the complexity of the fallback design, and we actually missed something. So I think like having a fallback approach is sound, but you need to really keep it simple and look at, look deeply at what the oracles are doing under the hood and your integration with them, not just kind of look at your price feed logic, So it's like looking at the whole stack beyond your system. I think that's really important, and keeping everything simple.
On that front as well, Rick, when you're looking at Oracle failures and I guess contingencies, are you thinking about having a circuit breaker in place for V2, or is that something that this is not something that you're looking at?
Yeah, it's an interesting idea, but it's the question there is like, what do we do if the circuit breaker is triggered? Like, does the system just pause and then what happens? Because if it's immutable, we can't step in and make a decision and kind of like look at an Oracle failure and assess whether to switch to a different one or something like that. It's more a case of we'd have to have some on-chain logic that makes that decision automatically. So then that circuit breaker just becomes a fallback, right? So it doesn't really make sense if you don't have governance, I think. But certainly some simple automatic fallback logic could make sense.
Cool, thanks for that. Back to Jayant and Jakub. I think what would be interesting to know is, what's coming up with you guys in terms of next versions of both your oracles. I think, Jayant, from your side, there's Pyth version 3 coming up. Would be interesting to hear what's coming up with that. I think on RedStone side, I think you guys have been on mainnet now for 9 months or so. Would also be interesting to hear, what you guys are working on, what path you're taking in terms of decentralization, security, and immutability. But yeah, Jayant, maybe you can take the lead here.
Sure. So, we actually just sort of soft launched a big upgrade to Pyth. So this basically increases the update frequency. So by like 2.5x, brings down gas cost to verify on chain, kind of depending on your use case, something like 30 to 90%. So some pretty substantial upgrades for Pyth users. That's kind of what we've been focused on right now. Some things that are coming up are, we've been thinking a lot about decentralized governance. This is, of course, something that I think every crypto protocol aspires to. But this is something that we really want to get out in the next couple of months, hopefully. Obviously, some issues around setting up governance and all that. But, we're working with some folks to figure out best practices and these kinds of things. I think those are the big things on our mind. There's some smaller things as well. I mean, really, there's no shortage of good ideas. It's just like a question of finding the time to actually do it. So, you guys probably know how it is.
Yeah, absolutely. And Jakub, from your side and from RedStone side?
Sure. I think we got a quite interesting approach to decentralization and governance, because like being in the space for at the moment 7 years, I've seen a lot of issues with DAOs, and sometimes they work really well if they got a good community, good distribution of tokens, etc. But sometimes when a person in DAO can control like 80% of the voting power, it's just an illusion of a DAO. Let's put it that way, and still there's like a lot of control in single hands. So we decided to give power to the protocols, and give freedom how they want to use our oracles in a way that they can specify at the integration point which data providers could be trusted. Obviously, if a data provider is not delivering data, or if the answers differ from the consensus, it will be automatically excluded. But in that way, a protocol has like a final say on the set of trusted data sources, whether they comes from the first party data providers, whether they comes from the on-chain environment. And this actually help us to avoid an, let's say, a controversial situation when there's a protocol integrated with RedStone, but actually we are the ones who pull the strings and we can add a new provider or remove a provider or change the specification of the protocol without the control of our users. So that's our approach to decentralization, give the power to protocol, and they can decide whether they want to have their own governance, whether they want to have things immutable like liquidity or any other choice, but it's the protocol's choice. I was thinking about other innovation in RedStone. We are still optimizing the price delivery process, both in terms of gas consumption, especially across multiple providers. So if we got like dozens of providers, how to still cut the cost, and also how to reduce the latency. So the usual stuff, just trying to make things better. But also we started working on something we call multi-dimensional price, which is possible because of the access to the on-chain data about slippage and liquidity from DEXs. So we want to provide to the end users not only like a spot price, not only, let's say, like a spot price with the possible confidence score, but also like with a way to estimate what will be the actual liquidation price for a given volume of assets. So for example, what will be the fair market price for, let's say, 10 millions of stake if they are to be sold on the open market. So I think a lot of protocols has been looking for that, especially for the less liquid tokens, and we are implementing that at the moment. And also, as we get a lot of data from the on-chain environment, we started exploring the possibilities of the zero-knowledge proof. So you do not need to trust the intermediary, and we can plug in the data providers with the automatic proving system. So you can have like a full trust in the data quality, that the information is being fetched on-chain without any tampering along the way.
Cool. Thank you so much for that, Jakub. Before I open it up to the audience to ask questions, I think, between you guys, based on the conversation we've had today, anything that you'd like clarification on or any questions, I think that'd be cool. What you like from Pyth's approach, what you like from RedStone's approach, and also maybe Rick from your side, if you had any questions for both of them.
Yeah, I guess in your roadmaps and white papers, you still there's talk of moving to token staking and like a token security model. How much will that play into things in the future? Like, will it just be kind of, I guess you'll still have some reputational aspects for the nodes. It won't just be purely token staking based. So yeah, how will that integrate?
Okay, I can take it first. So yes, we see in the future a role for token staking. I think is the most battle tested way of, let's say, like a decentralized mechanism to incentivize correct behavior in the blockchain space, has been proven by all of the proof of stake chains so far. But also, we do not want to be like a super naive and rely on the assumption that the value of the stake tokens will always be greater than the potential value at risk with other protocols, especially if we look at the value, like the market value of all of the oracles compared to the total value locked in DeFi, or the total value secured in DeFi. I do not expect that this number will be even. So apart from the staking, which could be obviously painful for the data providers if they provide any corrupted information or they're out of service. There is always a reputational piece. So a protocol should be aware to wisely select a list of the data providers, probably based on their past performance, but also on their identity and reputation in the real world. I do not see like this area can be like fully anonymized and distributed in the future. There's still needs to be this element of reputation, identity, and trust. And what we are also doing in RedStone, all of the data that's been provided by any of our data providers is permanently stored on the Arweave chain, which makes it easier to perform any due diligence. So every piece of data that was ever delivered, and at the moment I think we got more than 10 billion data point, is permanently persisted on Arweave, and it's fully open for anyone to check the real quality of a service of a given data provider.
I'm happy to answer that as well. So I think the staking for Oracle security question is an interesting one, and I think again, I think it's good to take a step back here and like ask, does the security model really work the same way as it does for layer one blockchains? And I think the answer to this question is no, because Jakub alluded to this as well, but basically for this to actually prevent a sort of coordinated attack, you need you need the value staked behind the Oracle to be greater than twice the value secured by the Oracle, right? In that case, if you slash like 51% of the stake, it's greater than, greater than the value that you can gain on the other side. And that's actually a very challenging thing to do, especially when you take into account the fact that the stake tokens have to earn a return on capital. So if you kind of just run through the math of like, okay, well, what's the return on capital? It's going to have to be better than the risk-free rate plus, some risk premium for the fact that like you can actually lose the tokens, you have to actually do some work, right? So you kind of run the math on that, and I have a hard time seeing how this is going to work. I mean, you would the Oracle would basically have to charge, every protocol like single-digit percents of value secured every year in order to like pay for Oracle security, which like that just seems implausible to me as something that could actually happen. Like it's too expensive. So I think that model is probably not going to work to prevent all types of attacks. I think staking is still a good model to kind of incentivize data providers to, not make mistakes and like, kind of optimize the delivery of prices to the protocol, right? Like make sure the code doesn't have bugs, that kind of thing. Attaching some, financial penalties to bad performance is definitely a useful thing there. But it definitely can't be the only security mechanism. So, with Pyth, our approach is basically to have these very high reputation data providers. All the data providers on the network are these like, major firms with like real lines of business that are not providing data to Pyth. And like, these guys are not going to get together. Just like as a realistic thing, these guys are not going to get together and like coordinatedly manipulate the price intentionally, because like, look, they're going to get sued, right? Like they're going to have a big problem, and like they're making, hundreds of millions of dollars doing something else. Like they're not going to risk that for this, right? It just doesn't make sense. So I think that kind of reputation model is probably the right one. And that's kind of going to be a piece of the security picture for Pyth as well.
Yeah, nice. Thank you. Yeah, it makes a lot of sense.
Cool. Thanks for that, guys. I guess for now it'd be good to kind of open it up to the audience. If you have any questions, please raise your hand and then I'll bring you up to the stage. We've got a quiet crowd today, it seems. In that case, I think we can start wrapping it up. Thank you guys again for joining the spaces today. Super informative. And Guys, if you've not seen, we posted a blog post on all things oracles where we do a kind of a side-by-side comparison of the criteria that we're looking at for Liquity V2. Also, if you're interested, please hop onto our Discord. We would love to have a discussion around not only oracles, but also V2 in general. And, any questions that you have, where the team is there to answer things there as well. But yeah, thanks so much for joining the spaces today. Thank you, Rick. Thank you, Jayant, and thank you, Jakub. And I think we can call it a day. Cheers, everyone.
Thank you.
Thanks for having us, Sam and Rick. Appreciate it.
Yeah, thanks for the invite. I think it's really great that you guys are hosting this space, and I think if there are more and more of these kind of events, it will help the whole Oracle space. So looking forward to seeing more opportunities to speak together about the future and security of oracles.